So don't freak out. We're dealing with radians today. So it says we already know the general form of cosine and sine. Really, this year we've done like we've been focusing on cosine. I'm trying to take a different path. Don't worry, we're going to talk about sine all day Monday. So here we go. All we know how to do right now, y equals a cosine, open parenthesis, b, open parenthesis, x minus c, close, plus d. I just went down the alphabet, a, b, c, d. Oh, man. Because Alvaro, those are not in my class, but they're here. I just don't want you to take points off. And then we're not at full capacity, but that's okay. We got to continue. All right. So when you go to the university, guys, or when you look at a different textbook, you might see this right here. Relax. It's the same expression. It's the same. The only difference is that some authors like to write with the B in there like that. So don't freak out. Okay. Are you guys ready? So a lot of this is already kind of similar to what we did yesterday. The only big difference is that this is in radians. That's the only big difference. So again, so it says, let's see what it says here. Find a particular equation for the sinusoid function. Sinusoid means it just goes up and down. It's just a wave. Notice the x-axis doesn't have degrees, so it must be in radians. So I don't have a little degree symbol like I did yesterday. So this is a radian. Are we okay, guys? All right. First move we make, we write y equals a cosine, open parenthesis, b, open parenthesis, x minus c, close, plus d. I just went down the alphabet. A, B, C, D. Those are the numbers I want. The easiest, bless you squared. The easiest thing to get, in my opinion, this is just my opinion, everyone's opinion is different, is the midline, which is what letter? I think that's the easiest one to get because it's right smack in the middle between the max and the min. Notice we're not referencing any formulas. If you do a Google, it's going to probably say max plus min divided by 2, but we don't need that. We're just using logic. This is going by 1. It looks like the lowest is 1. 1, 2, 3, 4. It looks like the highest is, what's the highest? 5. So D equals 5 plus 1, and I'm going to divide that by 2. 5 plus 1 is 6, and divided by 2 is going to be, so that's my midline. If you have colored pencils, this is the perfect place for that. I'm going to pick the color blue, and I'm going to go to 3, and I'm going to go. You do not need to do the sound effects. Are we still okay, guys? All right, next. The easiest thing, I think, from here is to get the amplitude. The amplitude is the distance from the maximum to the middle or from the middle to the minimum. It doesn't matter how. If this is 3 and that's 5, what's the amplitude? 2. Notice if you would have done midline minus the minimum, you still get 2 as well. Do you guys see that? All right. Next, we're going to be using cosine. So for cosine, we're looking at a peak. So I see a peak here at 1, and it looks like it's going by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep, it is. That's 11. So usually the rule of thumb is you want to pick the peak that's closest to the axis, the y-axis. So what value am I going to use for C? 1. If you want to be specific and put 1 to the right, that is fine. This is just like when you were in Algebra 2, guys. Exactly like when you're in Algebra 2. Now, to get the B, I need to figure out what the period is. If this were in degrees, I would do 360 divided by period. But I'm not in degrees. I'm in radians. So instead of 360, I'm going to use what? 2 pi. 2 pi divided by period. Well, I have a peak at 1, and I have another peak at 11. So let me go down here and write period first. So to find the period, peak to peak, 11 minus 1. And I get 10. So I'm going to replace that. So I'm going to write 2 pi divided by 10. That reduces to what over what? Pi over 5. We got everything we need, guys. Y equals, what's my amplitude? 2. Cosine, open parenthesis. What's the B? Pi over 5. Open parenthesis again. X minus 1, close, plus, what's the midline? 3. Guys, this is the same as when you were in Algebra 2. Don't become a robot. That 3 just makes this graph move up or down. You guys see that? This x minus 1, this right here makes this graph move left or right. And then that 2 is like a vertical stretch or compress. It should have been 1 up, 1 low, but why is it 2? Because I'm too high, too low from the midline. It's just like your algebra days. The only difference is we're working with sinusoids now. Does that all make sense? Okay, here comes the part where you guys make the biggest error. You just leave it alone and you go right to the next problem. Check your work. Does everyone have a calculator? So let's check it with a calculator because you're not going to have Desmos during your exams. And then don't worry, I'll show you with Desmos. So how you can do it with at home. On the calculator, when you get your calculator, click on y equals, upper left-hand corner. You should see the screen. And now what am I going to type in y1? That expression right here. So I'm going to write 2. The cosine is found on top. It's one of those black keys there, cosine. And then what was my b? Pi over 5. I like to do it like this, guys. Push alpha y equals so you can have a little fraction like that. See? How do I get the little fraction? Alpha y equals. And then put the pi. The pi is where the caret is at. Second pi over 5 like this. And then scroll to the right, open parenthesis. The x is right next to the alpha. X minus 1. Close it twice. And then plus 3.
Wait, how do you do the division right on top of each other again?
Say it again.
The division right on top of each other.
Alpha y equals. And then number 1. Yeah, ask me questions, guys. Does everyone look like that? Okay, don't push graph yet. Look at your graph paper. Click on something that says window. Do you see the window? All that literally means is, what do you want me to insert to make this window look like this graph? Well, look at this graph. What's the smallest x value you see here? -1. So I'm going to put -1. If you want to go a little bit to the left of that, that's fine. -1. And then the biggest x value that I see, let's see, 10, 11, 12, 13, 14, 15, 16, 17, 18. I see like 18. So we're going to put 18 for x max. X scale, you can leave it by 1 if you want. Not a big deal. Y min, so I look at my graph. What's the lowest y value you see here? I know not graphing, but like in the window here, the graph. I see -1, so I'm going to put -1. Do you guys see that? -1. What's the biggest y value you see on the grid here? 5, 6, 7. So I'm going to put 7. 7. And then scale by 1, that's fine. Do not mess with x res, that stands for resolution. Do not mess with delta x, and do not mess with trace step. All that is just language for how often they want to put pixels on the calculator. Push graph. Mine's faster than yours because mine's on a computer and yours is a little. And you should see this sinusoid. Does everyone have that sinusoid? All right, guys. Okay, here's how you fix it, or here's how you check to see if this is 100% legit. Ready? So I know that I have a max at 1. So on your graph, if you push the trace button and I push a 1, I better see that 5 right there. Do you guys see how we did that? Once you push trace once, you don't have to push it again. So look, what do I have a min here? That looks like 6. 1, 2, 3, 4, 5, 6. At 6, I have a min. So if I push 6 and I push enter, I better be at a min. And there it is, 1. Do you guys see how we did it? So this one works. Now, when you go home, you might not have a calculator. If you don't have a calculator, relax. You have access to Desmos as long as you have internet access. You can also use Desmos on your phone. So here's how you use it. Desmos. Come on, buddy. Go open Graphing Calculator. I'm using my hotspot, guys, so it's a little slower. All right, and then just, you guys are used to not typing y, but type in a y equals. Y equals, what was my amplitude? I already forgot, guys. 2 cosine, open parenthesis, pi over 5, open parenthesis again, x minus 1, close, plus what? All right, so there it is. You can fix it. You can click on the little wrench here, and you can tell it like x-axis between -1 and 18, if I remember correctly, or maybe 17. Well, it doesn't matter, 18, 17. And then y min, I think we said -1. And then y max, I think we said 7. And then look, there it is. And then if you hover over it and you click on the max here, look, it tells you 1, 5. And then you just verify it. You click on the min, look, 6, 1. So we got it. Does that make sense? So you don't need an 84 at home, guys. You just need an 84 when you don't have access to the internet, like paper exams. And then, yeah, how do we feel with that? Okay, let's go to the next question. Now we're going in reverse. What's up? Yes. Yes, but you'd have to click on the settings for degrees. Okay. By default, everything's in radians. All right, here we go, guys. You guys ready? All right, it says find the period, amplitude, phase displacement, and sinusoidal axis location. Use these features to sketch a graph. Confirm your calculator. Okay, before I do anything, I'm going to go y equals a cosine, open parenthesis, b, open parenthesis, x minus c, close, plus d. I just went down the alphabet. A, B, C, D is what we don't know. Absidy. Are we okay? All right. Looking at that, looking at this expression, and then looking at this expression, I can tell that my A has to be what? 5? Yeah, look. A has to be whatever's in front of that cosine there. The B is what? 2, and we're going to use that to find our period in a little bit. The C is what? Pi over 4 to the right, if you want to be specific, or just write pi over 4. And then the D, the midline is what? 8. We're missing the period. I know that B is 2 pi divided by period. We know that, right, guys? All right, so that means if you do basic algebra, multiply by period, divide by B, from there you can tell that the period has to be 2 pi divided by B. Do we have any questions on that? So I'm going to find my period by going period equals 2 pi divided by the B, which is 2. What's going to cancel out? It's just pi, that's the period. Chop, we've never done one of these with pi as a period. Relax, we'll be fine. That's supposed to be you. Right? I'm mimicking you guys, okay? LOL. All right, here we go. Draw a grid. It doesn't have to be perfect. I'm going to say this is my y-axis. And I can see that the midline is 8 and my amplitude is 5. So I'm going to be everything above quadrant 1. So I'm going to exaggerate and I'm going to say here's the x-axis. So do that. What am I going to draw first? I'm going to draw the midline first. My midline is at 8. So I'm going to say 8 is like right here. I'm going to put 8 and I'm going to do... You don't have to do the sound effects. Next, I'm going to get my max and my mins. So my amplitude is 5. So I'm going to go 5 above 8 and I'm going to go 5 below 8. What's 8 plus 5? So I'm going to say here's 13 and I'm going to go... You're not going to pass that line because that's the highest it goes. And I'm going to go 5 below the 8, which is what? 3 and then... Are we okay so far, guys? All right. Because we're using cosine, I know that I'm going to have a peak at pi over 4. So I'm going to take my red. I'm going to take a different color. And you don't have to be perfect, guys. I'm going to say pi over 4 is like right here. So pi over 4, and I'll put a point right at the maximum. Are we okay so far? Now, I know that this maximum repeats every what? Every pi. So I'm going to add pi. So down here, I'm going to show you guys how to... See, you guys are so used to calculators. I'm going to show you guys how to add pi really fast. This is how you add pi really fast. Maybe you already know. Maybe you already know. Look, if to make pi, you see that 4? You can just do this. 4 over 4. It's still pi. Do you see what we did there, guys? And then look, check it out. What's pi over 4 plus 4 pi over 4? What's 4 plus 1? So this next one, I'm going to say that this is 5 pi over 4 right here. 5 pi over 4 points. Oh, that's at the mid. At the max. You should be at the max, not the mid. Max. I'm going to add another pi. Boom. So just add 4 to 5. What's 5 plus 4? So this is 9 pi over 4. I'm going to add another pi to 9 pi over 4. So tell me, what's this new number? Yeah, what is it? Say it loud and proud. Yeah, 13 power 4. 13 power 4 points. Let's do another one. What's 13 power 4 plus pi? That's 17 power 4. And let's do one more. Do you see what we did there, guys? We're good, Wilbert? Okay. Because of symmetry, and I'll do it on both. In between your two maxes, you have a what? Not a point of inflection. In between two maxes, you have a minimum, right? So let me go and show it over there just in case. In between your two maxes, you have a min. Because of symmetry, it goes up and down. So right smack in the middle, you have a min. Chav, where's that at? Well, the middle between 1 and 5 is 3. So this must be 3 power 4. Do you see how we did it, guys? All right. If you add another pi to 3 power 4, you'll get another minimum. So right smack in the middle. Bam. That one is 7 power 4. Do you see how everything's working out? And then the rest, I'm not going to bother putting the scale. I'm just going to put the minimum down there like that. Just eye it. We're not looking for perfection. Are we okay so far? All right. In between, don't worry, we're going to figure out that graphic. In between the max and the min, now, in between the max and the min, I have a part of inflection because of the symmetry. So right smack in the middle between power 4 and 3 power 4, like right there. Chav, what is that value? Well, it's actually 2 power 4, which is like power 2. But I'll put 2 power 4 just so you can see the scaling. And then I'll do the next one too. The next one between 3 power 4 and 5 power 4, you have another point of inflection right smack in the middle in the x-axis, right? And that's in the midline. And that's 4 power 4, which is actually like pi. Do you guys see what we're doing? All right, keep putting the rest of the dots. Those are the only ones that I care about. Well, I mean, I care about all of them, but the ones I'm going to put on the grid here. Are you guys happy that you guys are here? Do you guys feel like you would have missed a lot if you wouldn't have come? All right. You are done. The maximums put upside down bowls. The minimums put bowls or parabolas, whatever you want to call them, and try to aim them towards the points of inflection like this. See? Try to aim, I don't know, what do you want to call these? Like fingers or branches? This is kind of tight. Okay. And then try to make the points of inflection happen at the midline. I didn't do the perfect job here, guys, because I can tell mine's a little off. Maybe I should have made mine a little thicker or a little wider, the scale. That's fine. And there it is. How do you guys feel? All right, let's check it. Let's just check it, see how we did. So I'm going to click on calculator. How do I check it? What do I push? Y equals. This is why I love these calculators, guys. If you have a TI Inspire, you have to okay. They're both. I love both calculators, but for speed, I like this one better. Type your equation. The equation is 5 cosine. So 5 cosine Alpha y equals, enter, so I can do a little fraction. Do I have a fraction there? Oh, no, I don't. Just 2. So delete 2, parenthesis, x minus, was it power 4? I already forgot. Yeah, power 4, so that one needs a little fraction. Second pi over 4. And then I'm going to close, and then put plus 8. Plus 8. All right. I'm going to click on what next? Window. And then I look at my graph, and I'm like, oh, well, I guess I don't start anything past 0 here. So I'm going to make x min 0. X max, I'm going to make it chop, but these are in terms of pi. That's fine. I'm going to make it 21 pi over 4. So I'm going to type in 21 pi over 4. And it's going to turn into a decimal, 16.49. That's fine. My x scale, you know what? I want to go by pi over 2 because I can see pi over 2 right there. So I'm going to make my scale by pi over 2. You can also make it the period if you want. Y min, I'm going to say y min, I'm going to say 0. And then y max, I'm gonna keep it symmetric. So I go to 13, so I'm gonna go 3 above, so I'm gonna say 16. 16. Y scale, no, leave everything alone, push graph, and there it is. Let's see if it's perfect. So how do I see if it's perfect? I'm gonna push the trace button, and I'm gonna type in pi over 4. So trace, and then look, just go pi over 4. So what you want to see here when you push enter, you don't want to see any decimals on the y value. Bam, and look at that. So you don't want to see 12.999, you don't want to see 13.00001, you just want to see 13. Cool, right? You know what, for kicks, I'm going to come over here and I'm going to put 8 on y2. And then look, that way I can see my midline. And so I know that I'm at the midline at pi over 2. So I'm going to put pi over 2, trace, pi over 2. I'm going to push enter. And voila, look at that. Perfect, right on the midline. Isn't that cool? And I'm going to test my minimum now. I know that I have a minimum at 3 pi over 4. So you don't have to push trace again if you already have it in this mode. I'm going to go 3 pi over 4. Wow, look at that. 3. Perfect. Cool or not cool? Could you do this also on Desmos if you don't have access to a calculator? Yes. How do we feel? Was today's lesson pretty easy, guys? Do we get it? All right, guys. Thank you guys for being here. Let me give you guys a handout. I kind of want the handout today, but if you turn it in Sunday, that's fine.